the geomagnetic storm event also increases. This can be manifested by the depth value during the ascending phase of solar cycle 25. Okay. Let's next for the 5 geomagnetic storms. Geomagnetic storm of May 14219. The geomagnetic storm of May 14219 can be analyzed using the different solar wind parameters such as solar wind plasma temperature, solar wind plasma speed, solar wind proton density, solar wind pressure, solar wind electric field, solar wind southward component of interplanetary magnetic field, and the DS index or disturbance storm time index. The geomagnetic storm of May 14219 initiated at 0 universal time with the depth value of -3 nanotesla and reaches to the lowest value of -65 nanotesla at 7 universal time. This storm shows the first moderate storm of solar cycle 25, and this storm is occurs due to CME and coronal hole high-speed streams. After it reaches the maximum value of the storm or the minimum value of the DS index, it starts the recovery phase, which attains its quiet time value on the early hours on May 1, 2019. It's also observed that the southward component of interplanetary magnetic field EMFBZ initiated to turn slowly southward at 0 universal time with -1.6 nanotesla and reaches to the lowest value of -3.1 nanotesla at 5 universal time. The EMFBZ turns southward shows magnetic reconnection. Magnetic reconnection, it indicates the transfer of solar wind energy into the magnetosphere. After it reaches the lowest value, it starts to turn northward, which attains its quiet time value on the late hours in the early hours on May 1, 2019. The solar wind electric field also increases from 0.4 millivolt per meter to 6.76 millivolt per meter due to enhancement of the ring current. After reaches the enhanced value, it achieves its quiet time value on the early hours on May 1, 2019. At the same time, the solar wind pressure increases from 3.66 nanopascal to 7.43 nanopascal as a result of the shockwave compression of the magnetosphere, which enhances the magnetic pressure. Due to the injection of heat energy into the magnetosphere and the ionized particle deposition coming from the sun, the solar proton density also raises from 10.1 to 15.7 number of protons per centimeter cubed. The solar wind plasma speed also raises or increases from 444 to 515 due to enhancement of solar wind pressure. The injection of heat energy in the magnetosphere shows a manifestation of change in temperature from 0.1 to 0.25 times 10 to the power of 5 Kelvin. Okay, Dr. Irenso, please. Time is.
Yes, Dr. You have time. You have 5 minutes or 8 minutes.
Okay, the second one is geomagnetic storm of April 2020. The geomagnetic storm of April 2020 was initiated with a storm sudden commencement at 7 universal time with the DS index of 20 nanotesla and reaches to the lowest value of -59 nanotesla at 12 universal time. This storm occurs due to variation of the solar wind parameters and CME. After reaches the lowest value, it starts the recovery phase, which obtains quiet time value on the late hours on April 2020. It shows a short recovery phase due to losses of the ring current. It's also noticed that the southward component of interplanetary magnetic field initiated to turn gradually southward at 7 universal time with 0.7 nanotesla and reaches to the lowest value of -1.4 nanotesla at 10 universal time. After it reaches the lowest value, it starts to turn northward, which to achieve its quiet time value on the late hours on. At the same time, the solar wind electric field also increases from 0.25 millivolt per meter to 5.5 millivolt per meter due to enhancement of solar wind conditions such as higher solar wind velocity and stronger magnetic fields. The solar wind pressure also, at the same time, the solar wind pressure also increases from 7.1 to
We finished it.
Okay, the geomagnetic storm of November 4, 2021. The geomagnetic storm of November 4, 2021. The geomagnetic storm of November 4, 2021 was initiated at 20 universal time with a storm sudden commencement with the depth value of 26 nanotesla and reaches to the lowest value of minus 105 nanotesla. This storm shows the first intense storm of solar cycle 25, and this storm occurs because of CME that ejected from the sun at an arrival time of at 3:24 universal time with a speed of 1473 km at an arrival time of 7 hours 41 minutes and 24 minutes. As calculated, the arrival time through the expression here. Arrival time is equal to the difference between propagation time and release time minus 24 hours. Since the distance from Sun to Earth is 150 kilometers, then the propagation time of CME can be expressed in terms of the difference between distance from Sun to Earth over speed of CME, and the release time is determined by observing the CME. Okay. Okay, the geomagnetic storm of November 7, 2022 was initiated with a storm sudden commencement at 9 universal time, and with the depth value of 13 nanotesla, and reaches to the lowest value of minus 92 nanotesla. This storm occurs due to variation of the solar wind parameters and CME.
You have 2
The
minutes.
phase one is the geomagnetic storm of April 24, 2023. The geomagnetic storm of April 24, 2023 was initiated at 0 universal time with the depth value of minus 14 nanotesla and reaches to the lowest value of negative 212 nanotesla. This storm shows the first ever storm of solar cycle 25. And this storm is occurred as a result of CME that ejected from the sun or that coming from the sun at 19 and 36 with a speed of 1284 km per second at an arrival time of 28 hours 3 minutes and 2 seconds.
Dr. Atade, I think you have only 1 minute. Sorry.
Okay, the electrodynamic and phase of solar cycle. Thank you.
Thank you. Sorry for rushing you. We have to stick with the schedule. I don't think we have time for questions, but feel free to ask. Dr. Atadis, through the chat.
Hello.
Yes. Hello.
Hello.
I can hear you.
Hello.
Can you hear me?
Yeah.
So we are gonna move to the next speaker. So the next speaker is Jiranya Amsalu. The title of his talk is Assessment of Natural Radioactivity in Soil Samples and Sugar at Arjo Didissa Sugar Factory. So please, Jiranya, can you share your PowerPoint?
Prof.
Yes.
Actually, Azada is not a doctor. She presents her master's thesis.
Okay, I apologize for that. I just want to be on the safest side.
Yeah.
To call her a doctor in case if she is a doctor. I'm sorry about that. Thank you. Jiranya, can you give my university? I'm not sure from which university.
Sorry, Jirenya has not communicated yet. So, can pass.
Well, in that case, then we can entertain questions because the next speaker is slotted for 11:30 a.m. my time. So we have a few minutes. So if you have any question to Dr. Yikdam and Atada, please welcome to ask them questions.
Patient from Arama University. Can we proceed, Professor Daniel?
Go ahead, please.
So, thank you. My question is to Dr. Igdam. So he did these stars which are found in the Large Magellanic Cloud, which do have a different proper motion. So I see on his graph some of those stars, they do have a negative proper motion. So I know that he uses Gaia data. Gaia has some systematic error, which gives a negative proper motion and parallax measurement. So my question is, while he was selecting his stars, how much is off from the systematic error of the Gaia data? And do you have, an explanation for those stars which do have a proper motion? Having a negative proper motion, what does that mean? This is my question for you.
Dr. Ikdam, would you
Okay.
respond to the question? There is a noise, there is an echo.
Okay. I think his question is that proportions, there are negative proportion in Gaia data. Yeah, there are negative as well as positive proportion. But in our case, since we are comparing or we are getting the proportion difference, the systematic error doesn't affect our data because we get the mean proper motion and then subtract it from the proper motion of the target stars. But the proper motion of the target stars is positive, so it doesn't affect our data.
Thank you, Dr. Ikdam.
Another question from my university.
Go ahead, please.
My question is go to Mrs. Azadeh. She presented about geomagnetic storm on different cases. For example, for electrical field, we are considering electrical survey for different exploration, and the magnetic survey for different exploration, and we are considering only for magnetic exploration to explore natural resources and the different activities or different anomalies. We are considering for magnetic, only for magnetic, geomagnetic storm affecting for data gathering or data collection. Until now, we didn't consider for electrical survey or electrical data collection. As she presented on her slide, and based on her research, geomagnetic storm can affect electrical field. And at what time geomagnetic storm is affecting our electrical data collection? What's your suggestion for different exploration geophysics, like electrical methods? Thank you.
Mrs. Azadeh.
Okay. Okay, geomagnetic storms in Earth's technical infrastructure vary uses and effects because these storms inject high energy particles into the magnetosphere and that affect ionosphere. Due to this, these storms can be used or effectable for Earth's technological infrastructure. Due to induction of voltage and current in the magnetosphere.
Thank you, Azadeh. And your advisor can also step in and respond to the question. That's also allowed.
Okay, Dr. Gigi is here. He can respond for the question.
Please go ahead.
Okay, if the question is clearly addressed to me, when the geomagnetic storm or the coronal mass ejections and other solar winds are arriving at the magnetosphere, they compress the Earth's magnetic field and produce the induced current in the equipments and satellites, whatever technologies in general. So due to this, then they can affect our technologies. For example, they may be power grids can be destroyed. Even communication can be. There must be a blackout in this communication blackouts and so on. So this can happen in different technologies. That's why we study these geomagnetic storms are very difficult to technologies. Therefore, we have to take care of this.
Great, thank you. So a break is scheduled at 15, and so I will give you early break. So we will meet again at 4:30 a.m. my time. So that means after 23 minutes, we will meet. And earlier, I don't know from which university I was asked to give a 2-minute interview or something. I can do that in these 23 minutes.
ሄሎ ዳንኤል
Hello,
ፍሬው ነኝ። ዩቱቡን አሁን እንትን ማድረግ ትችላለህ።
Yeah, I already okay. Yeah, I can stop it. Yes.
አሁን